In this video, we're going to graph some XY data. Our X is going to be the concentration of a potassium permanganate solution against Y, which is going to be the light absorbance at 525 nanometers for that. So we have some X data here, we have some Y data here, and what we want to do is make a calibration curve from that data. All of these concentrations are known pretty precisely, and we're going to use that calibration curve to calculate the unknown solution that we have right here. It had an absorbance of 0.429, and we're going to calculate from the calibration curve what the concentration of the unknown solution is. All right, so the first thing that we've got to do is make a graph from our X data and our Y data. And I'm going to go click over here, and I'm going to go up to Insert on the ribbon, and I'm going to go over here to Charts, and I'm going to choose the XY scatter plot. I'll choose this first one. Okay, so there's no data in there. I have an empty square that I can move anywhere I like. I'm going to right-click on this, and it will pop up options of things for me to do with what I just selected. And what I really want to do is put some data in here to start off with. So I'm going to say select data. And it brings me up a little form right here. I am going to add the data by hitting the add button. And I can give the data a name here if I want to. I'm going to leave that blank for this. It wants me to select the X values now. I can click on this little up arrow button, go over here to the X data, and select that. And then I can go over here to the Y data. And I'm dragging the mouse over that range and select that. And it's showing me here what the data looks like. I'm going to say OK. And that's all I want to add to this graph. So I'm going to say OK here. Now I'd like to put a chart title in, and I'd like to label the axes. So to get space to do that, I'm going to go up here to the ribbon and select Quick Layout. And the first layout has everything that I need. So I'm going to click on that. And my chart title here might be something like something like that. And my axis title, I'm going to label my axis molarity of KMNO4. And I am going to go up here and label my y-axis as absorbance, which has no units. Ordinarily I put the units on here, but absorbance is a unitless quantity. If I am picky about subscripts and that kind of thing, what I can do is go select what I want a subscript, go back to Home, and font on the ribbon right here. And I could, if I wanted to, select subscript for that so that that would look a little bit nicer. You do it again here. I'm going to just select the 4. And I'm going to go up here to Font and select Subscript. Okay, so I have a nice looking graph there. Now I want to add a trend line to it. I'm going to click on the points. That selects them. Notice that they all light up. And I'm going to right click on that. And that gives me a list of options that I have. I'm going to add a trend line. And notice it drew a nice line through there that went as close as possible to all of the points. And over here, it lets me format that trend line. It's a line. I could select other shapes here. Most of the time, we're going to be fitting lines here. And I want to show the equation y equals mx plus b on the chart. So I'm going to check this box, and it shows the equation there. I also want to display the r-squared value on the chart. The r-squared value tells you the fraction of the variation in the data that is explained by the line. In this case, that line explains 99.69% of the variation in the data. So that tells you in a very rough way how good your fit is going to be. This legend here is not terribly informative. If I want to get rid of it, I could just select it and delete, and that gives me a little more room. I am also free to move the trend line and the R² value around like that. So if I wanted to extract this graph then as a PDF file, I could do that. Select the graph, the handles around the edge all light up. I go to File, Print, and then I make sure that for my printer I have Microsoft Print to PDF selected there. And then if I say Print, it's going to go into a file. And it'll ask me then what I want the file name to be, and it'll save it there. I'm going to just cancel out of that. Okay, so we have our trend line. How do I calculate my unknown? Y equals m. M is the slope, 2273.6 times x. So 2273.6 is the slope, and the intercept, the y-intercept, which is where the line hits the y-axis, is 0.0063. Now, I could get those values down here by typing them straight off the graph. There's another way to do it. I can say slope, and here I'm going to calculate the slope again. I'm going to say slope is the function that I'm going to use. I type an equal sign because I have a calculation here. I type a left parentheses, and now it wants me to select the known y's, put a comma, and then the known x's. So here are the known y's, comma, and the known x's. And now I have the slope. Notice it is the same number that I have over here, but it's not rounded off this time. And I can do the same thing with the intercept. I'm going to say equals intercept. It wants the known y's, comma, the known x's. And notice again, it's the same number that it gave me up here in the trend line, except here it's not rounded off. Now, the equation is y equals mx plus b for a line. And what I really want here is that if that's the y value, what's the x value for the unknown solution? So if I solve this equation for x, I'm going to get the x all by itself on one side. I'm going to subtract b from both sides of the equation, and I get something like that. And then if I divide both sides by m, that is going to give me x all by itself on one side. So that's how I'm going to calculate the unknown concentration here. If I say equals parentheses y minus b is what I want to have in here. Here's the y value I have for the unknown, minus the intercept, close the parentheses, divided by the slope. That should give me the concentration. Now let's see if that makes sense. It's hard for me to compare these because these are in scientific notation and this is not. I can get this into scientific notation easily enough. I'm going to right click on it, go to Format Cells, select Number, and scientific notation is what I want. Then it'll give me the concentration in scientific notation. So now it's easy for me to compare these. It looks like it's between these two, right? Well, here it's 1.86, so it's just under C. It's just under this one. If that were true, if it was close to C, the absorbances should be close, and they are pretty close right here. So that does make sense that this unknown concentration should be close to C because the absorbance here is closer to C than any of the other